When we were talking about systems of linear equations, we learned two distinct methods for solving them. We learned the substitution method and the elimination method. The substitution method is a method you can use to solve any system of equations, whether it's linear or not. The addition method can sometimes be used in nonlinear equations, but not always, or at least not always easily. Now this example I'm actually going to solve both ways. This is a system of nonlinear equations that I can actually solve by substitution or by elimination. Let's start with substitution. If I look at the bottom equation and I imagine adding y to both sides, I would get 2x squared equals y. I can then substitute that in for y in the first equation. So x cubed plus y, which is now 2x squared, is equal to 0. Now I have a polynomial equation I can solve by factoring. Factor out the greatest common factor of x squared, and I'm left with x squared equals x plus 2. Setting both pieces with a variable equal to 0, I have x is equal to 0 and x is equal to minus 2. So I'll have two ordered pair solutions, and now all I have to do is find y, which I can use this equation to do. X is 0 means y is also 0. Minus 2 squared is 4 times 2 is 8. And there are my two solutions. Okay, well, I told you I was going to do this one both ways, so let's imagine I have that original system again, x squared plus y equals 0. 2x squared minus y equals 0. Because I see a plus y and a minus y, I can go on and add the two equations together to eliminate the y's. I'd have x cubed plus 2x squared. The y's cancel, and 0 plus 0 on the right-hand side gives me 0. And I actually see this exact same equation that I've already solved. So now I know for sure that using either method, I would end up with the same two solutions. Here at the end of the video, though not instructed to do so, I thought we'd take a look at the graph of both equations. Because what I know for sure is that my two equations here, when I graph them, they're going to intersect at those 2 points we found. So they're going to intersect at the origin and at minus 2 comma positive 8. The bottom equation, y equals 2x squared. Well, that's a parabola. And so I know the vertex is at the origin. And if I was to imagine plugging in a 1, I'd get out a 2. If I plugged in minus 1, I'd also get out a 2. And then I have that point up there I know I go through. So I'm just going to draw my parabola going through those points. So there's the graph of that bottom equation. Looking at the top equation, if I get y by itself, I would get y equals minus x cubed. And so I know that's the graph of a cubic function. If I were to plug in a minus 1, I'd get out positive 1. If I plug in positive 1, I'll get out minus 1. And I know this point is also on that cubic function. So here are the graphs of those two polynomial functions. And we see the solution to the system of equations is their intersection points. And that's always a good way to think about those solutions.